September 1945. A Japanese engineer watches. 30 million kilowatts of American power light up Yokohama harbor in 3 days. His own grid took 40 years to build and 4 years to die. What he realizes in this moment changes everything. Welcome to History of World War II, where we dig into the moments that reshaped our world. If you're new, subscribe now, and to our loyal viewers, thank you for being here. Let me ask you something before we begin. What would you feel watching your enemy restore your nation faster than you ever could? Keep that question in mind. Act 1. The Calculation of Doom, Autumn 1941. 3 months before Pearl Harbor. Lieutenant General Taichi Suzuki sits alone in his Tokyo office, and he's doing math that terrifies him. He's not a dreamer or a politician. He's president of the Cabinet Planning Board, an engineer of national resources. And tonight, the numbers are telling him something undeniable. Oil reserves, 18 months of combat operations. Maybe? Steel production. Japan produces 6.8 million tons annually. The United States produces 75 million. That's 11 to 1. Already impossible. Electrical output. Japan generates 78 billion kilowatts AIs at peak wartime capacity. America generates over 270 billion kilowatts AIs. Suzuki puts it in writing, and his words are chilling. If the present condition is left unchecked, Japan will find herself totally exhausted and unable to rise in the future. He's not talking about tactics or strategy. He's talking about the physics of industrial war. Admiral Osamu Nagano tells Emperor Hirohito the same thing. The combined fleet has enough fuel for 1 year, maybe 2 if they're extremely careful. After that, the battleships become anchored, steel islands, mobile, useless, decorative. Here's what most people misunderstand about Pearl Harbor. The decision to strike was unborn from confidence. It was born from desperation. A gamble that American political will would break before Japanese economic reality crushed them. But the engineers already knew the truth. They'd already done the calculations. By 1945, the numbers became even more brutal. America was producing 80 million tons of steel. Japan produced 599,000 tons. Not 11 to 1 anymore, 133 to 1. Think about that for a moment. 133 to 1. The collapse wasn't tactical. It wasn't about better generals or braver soldiers. It was mathematical. It was inevitable from the moment the first shot was fired. But beneath all those steel statistics was something even more fundamental. Something that powered every factory, every shipyard, every weapons plant: electricity. And Japan's electrical system had a fatal flaw that couldn't be fixed. Act 2. The grid that couldn't talk to itself. Here's a problem that sounds technical, but was actually catastrophic. Japan's electrical grid was split in half, permanently, physically, irreversibly. Eastern Japan, Tokyo, Yokohama. The entire Kanto industrial belt ran on 50 Hz frequency. Western Japan, Osaka, Kobe, Kyoto ran on 60 Hz frequency. Why? Because in the 1890s, Tokyo imported German generators that ran at 50 Hz. Osaka imported American generators that ran at 60 Hz. 2 different systems, completely incompatible. Do you understand what this meant during a total war? When a thermal power plant failed in Tokyo, the hydroelectric surplus from the western mountains couldn't fill the gap. The power couldn't cross the frequency divide. It was physically impossible. You had excess electricity on one side of the country and blackouts on the other, with absolutely no way to transfer it. Japanese engineers spent 4 years of war improvising, rationing, and watching their grids slowly suffocate, and it got exponentially worse. American submarines cut off the coal shipments that fed Japan's thermal power plants. One by one, the power stations went cold. Engineers scrambled to keep critical munitions plants running, stripping power from civilian sectors, hospitals, residential areas. By summer 1945, the electrical grid wasn't just damaged, it was dying. Nippon Hassoden, the state-controlled power monopoly, existed in name only. The lights were going out across Japan, and there was no fuel to turn them back on. But Japanese engineers were about to witness something they could never have imagined. Something that would make those grid problems look trivial. Question for you. Do you think Japan's leaders understood how outmatched they were? Or did they convince themselves spirit could overcome steel? Drop your thoughts below. Act 3. The Impossible Repair. May 1942. Battle of the Coral Sea. Japanese pilots return with reconnaissance photographs of the American aircraft carrier USS Yorktown. The damage is extensive twisted metal, fires raging across multiple decks, structural damage to the flight deck and hull. Japanese naval intelligence analyzes the photographs carefully. They calculate repair time based on their own shipyard capabilities, their own industrial capacity. Minimum 3 months, probably 6. That carrier is out of the war for the foreseeable future. 4 weeks later, June 4, 1942, Battle of Midway Yorktown appears on the horizon. Fully operational. Japanese commanders stare in disbelief. How? How is this possible? How did the Americans repair that level of catastrophic damage in 28 days? Here's what actually happened, documented in U.S. Navy records. The Yorktown limped into Pearl Harbor on May 27, 1942. Before the ship even finished docking, 1,400 repair workers were assembling on the pier. They swarmed the carrier immediately. They worked around the clock, 24 hours a day, under massive floodlights powered by mobile generators. The Americans brought rolling power plants directly to the dockside, delivering massive amperage straight to welding arcs, cutting torches, hydraulic pumps, every piece of equipment that needed electricity. They didn't wait for base infrastructure to catch up. They didn't ration power or schedule shifts around electrical availability. They brought their own electrical grid on wheels. The Yorktown sailed again on May 30th. 3 days of repairs. 3 days of work that would have taken Japanese shipyards 3 to 6 months. This was the first glimpse of what would later restore Tokyo. Japanese engineers didn't know that yet. But this moment planted a seed of understanding. American industrial capacity operated on a different scale entirely. If you're starting to understand what industrial supremacy actually means, hit that like button, because what comes next will blow your mind. Act 4. The piston in his hand, early 1945. Yokosuka Naval Air Technical Arsenal. Japanese forces recover a downed F-4U Corsair fighter from a crashed site. They transport it immediately to the Naval Research Facility. Engineers swarm the aircraft, documenting every detail, disassembling it completely. They strip down the Pratt Whitney R2800 double wasp engine piece by piece, laying out components across examination tables. One engineer picks up a piston. He turns it over in his hands, examining the machining, the tolerances, the finish quality. And he's stunned. The precision is extraordinary. Every part is perfectly interchangeable. Mass-produced with tolerances that Japanese industry could only achieve through painstaking hand finishing by master craftsmen, one part at a time, slowly, carefully, expensively. The Americans were producing these engines by the thousands, 18,000 of these engines during the war. Every single part fit perfectly into every single engine. No adjustment needed, no skilled craftsman required. No hand finishing. Perfect, interchangeable, mass-produced. That engineer understood immediately. America wasn't just producing more. They were producing at a level of industrial sophistication Japan couldn't match. The gap wasn't just quantity. It was quality at quantity. He's holding American industrial supremacy in his hand. A single piston that represents an entire manufacturing philosophy Japan had never mastered. But here asks the question nobody was asking yet. What happens when that same industrial power turns toward restoration instead of destruction? What happens when the nation that can build 18,000 perfect engines decides to rebuild your electrical grid? Act 5. The Steel Horizon, August 30, 1945. General Douglas MacArthur's C-54. Skymaster touches down at Atsugi Airfield. Photographers capture the moment MacArthur in his aviator sunglasses, his corncob pipe, his casual confidence. But that's not the real message. The real message is sitting in Tokyo Bay. The Third Fleet, battleships, fleet carriers, light carriers, cruisers, destroyers, destroyer escorts, oilers, ammunition ships, supply vessels, hospital ships, repair ships. The horizon is erased by American steel. You cannot see where the ships end and the sky begins. It's just steel and sea and sky, blurred into one overwhelming statement of industrial capacity. Foreign Minister Mamoru Shigemitsu stands on the shore, watching. He writes in his diary that night about the psychological weight of witnessing overwhelming force made manifest and undeniable. Japanese officials had known the war was lost. They'd known it for months. But seeing this, experiencing the physical reality of American naval power, was different. This wasn't abstract statistics. This was steel and smoke and the low hum of hundreds of engines. The war is over. Everyone knows it. But what comes next? That's the real story. That's what nobody expected. Act 6. The Humming Barge, September 1945. Yokohama Harbor. A Japanese electrical engineer stands on a dock, and he's watching something that shouldn't be possible. A massive American barge sits in the harbor, and it's humming. A deep, industrial hum. The sound of turbines spinning, of generators producing electricity, of American power being pumped directly into Japanese soil. This engineer, his name is recorded in occupation files. But what matters is what he's witnessing has spent 4 years managing a dying electrical grid. For years rationing power. For years watching thermal plants go cold because the coal ships stopped arriving. For years making impossible decisions about which factories get electricity and which go dark. And now this. The Americans didn't just win the war. They brought their entire industrial civilization with them. And they're plugging it directly into Japan's ruined harbors. The SS Jacona converted cargo ship that had been generating electricity for New England 20 megawatts of electrical capacity. They sailed it across the Pacific Ocean and docked it at Yokohama Harbor. A floating power plant. The Power Barge Impedance, purpose-built, 30 megawatts of generating capacity. It arrived in Manila first, then Korea, then rotated to Japanese ports. A mobile electrical grid that could be repositioned wherever it was needed. Destroyer escorts like USS Wiseman and USS Marcia originally designed for submarine warfare. Hunting U-boats in the Atlantic, but they carried generators that could provide shore power. 3 to 6 megawatts each. Armed, self-mobile, self-defending power stations. Japanese engineers watch American crews connect massive cables from ship to shore. Thick cables carrying thousands of volts. Then the turbines start spinning. The hum, that deep industrial hum that had been silent for months. The sound of electricity being generated. The sound of power returning. The sound of lights coming back on. It's back. But it's not Japanese power. It's American power. Imported, delivered, operational within weeks of occupation. One Japanese engineer, his testimony is documented in occupation records, describes it as scientific wizardry, not technology, not engineering. Wizardry because the scale and speed were completely beyond his frame of reference. Here's the number that tells the whole story. The Americans restored major urban power supplies in 8 months. 8 months, a grid that took 4 decades to build, that took 4 years to destroy. Stabilized and operational in 8 months. How? By treating logistics not as a support function, but as a weapon system. The same system that delivered fuel and ammunition to Iwo Jima and Okinawa now delivered coal and diesel to Japanese power plants. The same supply ships that fed the Third Fleet now fed Japan's industrial belt. The same organizational capacity that won the war now focused on reconstruction. Think about these comparisons. Japan built 17 aircraft carriers during the entire war. America built 141. Japan produced 76,000 military aircraft over 4 years. America produced 324,000. Japan built 68,000 trucks. America built 2.4 million. And now that same industrial metabolism, that same organizational capacity, that same logistical sophistication was turning its full attention toward reconstruction. Not because America needed to, because America chose to. This is the moment Japanese engineers truly understood what they'd been fighting. Not just a military, not just an economy. An industrial civilization so profound, so systematically superior, it could destroy and rebuild with equal efficiency. The engineer on the dock watches the American barge hum with electrical output, K, and he understands something that changes his entire worldview. Act 7. The devil makes a deal. Yasuzaemon Matsunaga watches this transformation with particular interest. They called him the Devil of Electric Power, a nickname earned from his aggressive business tactics in the 1920s and 30s. He'd built regional power companies through fierce competition and innovation. Then the militarist government centralized everything, creating Nippon Hassoden, the state monopoly. Matsunaga opposed it. He argued that centralization would kill efficiency. They marginalized him. Now, in occupied Japan, the Americans want his help. Matsunaga sits down with Supreme Commander for the Allied Power Staff. They ask him how to rebuild Japan's electrical system. And Matsunaga doesn't just give them a repair plan. He gives them a revolution. No more single monopoly. Break it up. Create 9 regional power companies. Competition, efficiency, modern regulatory frameworks, American-style utility management. The Americans agree. They're not just plugging in floating power plants as a temporary emergency measure. They're redesigning Japan's entire electrical infrastructure. They're teaching, sharing technical knowledge, providing equipment that Japanese industry can't manufacture, transferring decades of American electrical engineering expertise. The engineer on the dock isn't just watching. He's taking notes, measuring amperage, calculating load distribution, learning voltage regulation techniques, absorbing every detail of how American systems work. Because here's what he's beginning to understand. The war had been fought on the premise that spiritual superiority could overcome material superiority. That Yamato Damashi Ita, spirit of Japan. The soul of the Japanese people could defeat American industrial might through sheer force of will and sacrifice. The floating power plants humming in Yokohama harbor proved something different. Material superiority, when applied with precision and purpose, had a spiritual quality of its own. It brought order from chaos, light from darkness, hope from despair. The Americans had proven they could burn Japanese cities to ash in months. Now they were proving they could do something far more difficult. They could make Japan viable again. And they were doing it faster than Japan could have done it alone. Act 8. The knowledge transfer, the restoration continued through 1946 and into 1947. American fuel imports sustained the thermal plants that had gone cold. The floating power assets rotated between critical nodes, Yokohama 1 month, Tokyo the next, then Osaka, then back to Yokohama, stabilizing the grid wherever it threatened to collapse. But something else was happening. Something more important than the megawatts being delivered. The Japanese engineers who were taking notes weren't just copying American designs. They were adapting, learning the underlying principles. Improving. American electrical engineers held training sessions. They explained load balancing techniques. They demonstrated modern safety protocols. They shared regulatory frameworks that had taken America decades to develop. Japanese engineers attended these sessions with notebooks and cameras. They asked questions. They challenged assumptions. They absorbed everything. By 1950, when the Korean War began, Japan had become the factory for UN forces. The industrial base that had been destroyed in 1945 was now producing equipment, vehicles, and supplies for American military operations in Korea. And to support that production, the U.S. military invested heavily in upgrading Japan's power infrastructure. Those floating power plants shuffled between Japan, Okinawa, and Korea, creating a regional energy security umbrella that served multiple strategic purposes. The engineer who watched that American barge arrive in Yokohama Harbor in 1945 was now, in 1950, supervising reconstruction projects, using American techniques, following American standards, applying American precision to Japanese problems. And he understood something profound. The war had proved American industrial supremacy. The speed, the scale, the sophistication undeniable. The restoration proved American industrial generosity. The choice to rebuild rather than simply occupy. But the rebuilding, the knowledge transfer, the investment in Japanese capacity that proved American industrial wisdom. Because the United States didn't just demonstrate the capacity to destroy, it demonstrated the capacity to choose mercy instead, to turn the same factories that built bombs into factories that built generators, to redirect the same logistical networks that delivered destruction into networks that delivered reconstruction, the same B-29. Superfortresses that had firebombed Tokyo were now delivering food and medical supplies during the occupation. The same industrial base that produced weapons now produced aid. The same electrical expertise that powered American war factories now powered Japanese recovery. This wasn't weakness. This was the ultimate expression of strength, the ability to rebuild what you destroyed, to make your former enemy viable again, to invest in their future because you understood that regional stability served everyone's long-term interests. Act 9. The numbers return. Lieutenant General Taiichi Suzuki, the man who calculated Japan's defeat in 1941, stands in Tokyo in 1947. He's watching American power restore Japanese cities. He's seeing the floating power plants. He's reading reports about the new regulatory frameworks being implemented. Those calculations he made in 1941 take on new meaning now. Yes, Japan lost. Mathematically, inevitably, the numbers didn't lie. 133-1 steel production by war's end. The physics of industrial warfare made victory impossible. But America's response to that victory wasn't occupation for the sake of dominance. It wasn't extraction or punishment or permanent subjugation. It was restoration. Rapid, efficient, generous, strategic. The floating power plants weren't just emergency measures, they were symbols. Physical proof that American industrial capacity could be applied to construction as effectively as it had been applied to destruction. And Japanese engineers absorbed that lesson completely. They didn't just restore the electrical grid, they improved it. They took the regulatory frameworks Matsunaga and American advisors proposed and refined them. They studied American technical standards and adapted them to Japanese conditions. They learned American management techniques and made them more efficient. By the 1960s, Japan's electrical infrastructure was world-class. By the 1970s, it was teaching other nations: efficient, modern, reliable, innovative. The nation that couldn't power its own cities in 1945 was exporting industrial equipment globally by 1970. The engineer who watched that American barge in Yokohama Harbor in 1945 was, by 1970, designing electrical systems that rivaled and sometimes exceeded American technology. Not through copying, through learning, adapting, innovating, improving. Could this transformation have happened without American intervention? Could Japan have rebuilt this quickly on its own? Share your opinion in the comments. That transformation doesn't happen without the restoration. Without those 8 months when American floating power plants stabilized a dying grid. Without the technical knowledge transfer that American engineers provided freely. without the investment in Japanese recovery that America chose to make. The United States proved it could win a war in 4 years against a determined enemy fighting on interior lines with powerful defensive positions. It proved it could restore a devastated nation's electrical infrastructure in 8 months. Faster than that nation could have done it alone. And it proved that industrial supremacy, when combined with strategic vision and deliberate choice, creates something more powerful than military victory. It creates partnership. The story of those 30 million kilowatts isn't just about electricity flowing through wires. It's about what happens when overwhelming force chooses mercy over vengeance, when mathematical inevitability meets human choice, when the nation that calculated your defeat decides to invest in your future instead of exploiting your weakness. Japanese engineers didn't just witness American power in September 1945. Standing on docks in Yokohama, watching those barges hum with imported electricity, they witnessed American purpose, and they took notes. They built better. They became competitors, then partners, then innovators in their own right. That's the real legacy of those floating power plants humming in Japanese harbors in 1945 and 46 and 47. Not just restored electricity, restored possibility. The lights came back on in 8 months. But what those lights illuminated was something far more significant than darkened streets and silent factories. They illuminated a path forward. A model of how industrial power could be applied to reconstruction with the same efficiency it had been applied to destruction. A vision of what becomes possible when strength chooses wisdom over domination, when victory chooses investment over extraction. The engineer on the dock in Yokohama understood it then. Standing there in September 1945, watching American power literally flow into Japanese soil. We understand it now, 80 years later, seeing the results of that choice play out across decades. The war was lost before it began. The mathematics guaranteed it. 133-1 steel production. 270 billion kilowatts versus 78 billion. The physics of industrial warfare. But the peace created something neither side imagined in 1941 when those calculations were first made. A future where the nation that calculated defeat becomes the nation that calculates efficiency. Where the grid that died was reborn stronger, smarter, more resilient. Where the lesson isn't simply about who won the war, but about what victory made possible when combined with wisdom. 30 million kilowatts of American electrical capacity delivered by floating power plants across the Pacific. 8 months of intensive restoration, impossible without that industrial base. 70 years of transformation, from devastation to partnership to innovation. That's the real story of what Japanese engineers realized when those American turbines started spinning in their harbors in September 1945. Not just that they'd lost a war, but that what came after loss, what came after that moment of standing on the dock watching impossible amounts of power arrive in 3 days could be something worth building together. What do you think? Could spiritual determination ever overcome industrial supremacy? Or does material reality always win? And more importantly, was America's choice to rebuild Japan's strategic genius or genuine generosity? Share your perspective in the comments. If this story changed how you see history, hit that like button and share this video with someone who needs to see it. Subscribe to History of World War II for more deep dives into the moments that textbooks skip. We post every week. Thanks for watching. See you in the next one.